The reaction between silver ion and solid zinc is represented by this equation here. A 1.50 gram sample of zinc is combined with 250 milliliters of 0.110 molar silver nitrate at 25 degrees Celsius. 1. Identify the limiting reactant. Show your calculations to support your answer. 2. On the basis of the limiting reactant, determine the value of the concentration of the zinc ion after the reaction is complete. Assume that volume change is negligible. B. Determine the value of the standard potential for a galvanic cell based on a reaction between silver nitrate and solid zinc at 25 degrees Celsius. Another galvanic cell is based on the reaction between silver ion and copper solid, represented by the equation below. At 25 degrees Celsius, the standard potential is 0.46 volts. C. Determine the value of the standard free energy, delta G naught, for the reaction between silver and copper. And now we start with the answers. Identify the limiting reactant. To determine the limiting reactant, calculate the number of moles of silver ion and zinc that are initially present in the solution. Well, here's the zinc. You have 1.0 grams of zinc. This is its molar mass. So we have 0.023 moles of zinc, and we of course get that from the periodic table. For the silver nitrate, here's the molar solution. We have 0.250 liters. That's 0.0275 moles of silver nitrate, which gives us 0.0275 moles of silver ion. Since there are 2 moles of silver ion required for every 1 mole of zinc, right up here, to react 0.023 moles of zinc, 0.046 moles of silver ion would be needed. Therefore, silver ion is the limiting reactant. Now determine the value of the concentration of zinc ion. Since silver ion is a limiting reactant, the complete reaction will consume 0.0275 moles of silver plus silver ion. So our moles of zinc will be, here's the moles of silver. We have 1 mole of zinc ion to 2 moles of silver ion. So that tells us we have 0.014 moles of zinc ion. The concentration then is the moles here, and the solution is 0.250 liters. So the concentration is 0.056 molar. Determine the value of the standard potential for the galvanic cell based on the reaction between silver nitrate and solid zinc. First, find the reduction potentials for the half reactions, and then determine where reduction is taking place and where is oxidation. Well, reduction is taking place here because it has the higher value, and this is the most negative here, so that's oxidation. The value for the silver ion does not need to be multiplied, as E naught is an intensive property. We then have E cathode minus E anode, and cathode, of course, is going to be where reduction takes place, so that's 0.80 minus a minus 0.76, and we get 1.56 volts. And the half reactions are down here if you were to be asked for that. Determine the value of the standard free energy, delta G naught, for the reaction between silver plus and copper solid at 25 Celsius. We use this equation right here. The N value for this reaction is the number of moles of electrons transferred. Since copper goes from a 0 oxidation state to 2+, there must be 2 moles of electrons. So N is equal to 2. Here's Faraday's constant. Here's the potential we found on the previous slide, and it's minus 88 kilojoules.